welcome back. We're back with example 2 on antiderivatives. We already did one example earlier. Guys, each example is going to be a little bit more challenging and more steps. So let us look at this example 2. So here I have three terms combined together, and we want, some of them are trig functions and some of them are algebraic functions. So let's see how we can do this. Guys, please do me a big favor. Have your formula sheet in front of you or a textbook where you can actually find the formulas. Okay, so let us start with this one. The first thing that we want to do is, since these are three terms, we are going to break it into three different terms. Starting with the first one, so there's a 2 cosine x, and then I have to distribute that dx with each of them. Then this guy, guys, I'm already going to do something about this so that it looks like that it looks into a form that we have like on our formula sheet. Because if I just look at this guy right here, I cannot see that on my formula sheet right now. Okay, so I have to convert it into a form that is visible on the formula sheet. So what we can do here is, well, leave the 4 here. We can rewrite this as cosine x over sine x, and then times 1 over sine x. Guys, cosine x, I just left it here like that because I could not really simplify that. But sine square x, I can rewrite that as sine x times sine x. So I just combine them like this. I just group them like this. And of course there's a dx, and then plus integral, then there's a 3. And radical x, I'm going to write that as x to the power 1/2. And we have to try to write the polynomial functions or algebraic functions as x to the power some exponents. So radical, we know radical is to the power 1/2. Okay, because for radicals, for algebraic expressions, we want them to look like of the form x to the power n, so that we can use the power rule. Now let us go from here. Guys, we already know what to do with the constants. You just take out the constants. You don't really have to really worry too much about the constants when they are multiplied. You just take them outside, okay? And then you're left with the cosine x dx. And one should take the constants out before one like gets the function, and then look at the formula sheet or the textbook and see what we can do from there. Then this, again, minus 4, I'm going to take that out. And then, guys, keep in mind cosine over sine is cotangent. Okay, this is one of the basic trig identities. And 1 over sine, you know, 1 over sine is the cosecant, because sine and cosecant are the reciprocal of each other. So the other term here would be cosecant x, and then of course there's a dx plus 3. I'm going to take that outside, and then x to the power 1/2 dx. Guys, writing the steps is very, very important here so that we don't make any mistakes. These simple basic ones are not too difficult, but if we skip steps, we can make mistakes here as well. Now let us look at the formula sheet and see if we have a formula for the integral of cosine, and you will find a formula for integral of cosine, which is simply sine. So it is sine x. Okay. Keep in mind that derivative of sine is cosine, and derivative of cosine is negative sine. But with this, with the antiderivatives is slightly different. The signs also change. So integral of cosine is just positive sine. So that takes care of this. You can see that from the formula sheet. And then here, guys, I have minus 4. There is a formula for the integral of this whole thing, which you can see on your textbooks or your formula sheet, and that is simply minus cosecant x. Okay, and then there's a plus 3. The integral of this can be evaluated using the power rule, where you have to just add 1 to the exponent and divide by the same thing. So it's x to the power 1/2 plus 1, and then in the denominator you will have the same exact thing. 1/2 plus 1, you divide by 1/2 plus 1, and of course there's a plus c. We're going to put that plus c here as well. Okay, guys, let us try to simplify further. It's 2 sine x. It cannot be anything. We cannot do really much with this. Negative 4 times negative is positive 4 cosecant x. So 2 terms are done here. Guys, we can simplify this. There's 3, and x to the power 1/2 plus 1 is 3/2, and this is going to be 3/2 here as well, and then plus c. We still cannot leave it like this. Guys, we know we have a fraction here, so we want to just get rid of this division, change it to a multiplication. So when we do that, I can write it in the next step. So it's 2 sine x. We just have to rewrite the other 2. And then this is going to look like 3 times, okay, I don't want you to get confused. So 3/2, when I change this division to multiplication, it reciprocates. So it's going to be 2/3 times, and then I have this whole thing, 3x to the power 3/2, and there's plus c. What's going to happen with this 3 and this 3? One is upstairs, one is downstairs. It's just going to cross out. So what are we left with? So final answer is 2 sine x plus 4 cosecant x, then 3's cross out, it's just plus 2 x to the power 3 halves, and then plus a constant of integration. Guys, this is the integral of these three functions. Okay, that's example 2. We had to do some extra work here, but we still had to use the power rule, and then we had to use some rules like from for the trig functions as well, which you will have on your formula sheet or in the textbooks. Or I mean, at some places you may have to actually remember all this. So if that is the case, please do remember these things and then use them when you are trying to actually solve examples. Guys, this is example 2. I will see you in the next video.